Assessing a mooring line's reliability requires an understanding of its ability to handle the conditions it is designed for, as well as the unplanned events that inevitably occur. It's important to remember that the mooring lines are the working components of a mooring system. Even though winch brakes are meant to serve as the first line of defense against overloading, it is the lines and tails themselves that are absorbing energy from the environment. And for this reason, they are typically the first component to fatigue. This is why understanding their performance and selecting lines that can withstand extreme conditions is crucial to ensure the correct safety margin in your operation throughout the entire lifetime of your lines. This may seem obvious to some, but mooring line durability is not typically considered in the early phases of vessel design. Instead, the designer or shipbuilder will use the guidelines set forth by OCIMF or IACS to determine the vessel's requirements for rope strength and system elasticity through a series of simulations. These simulations utilize a standard environmental criterion to confirm that the rope's initial strength provides sufficient safety margin. However, they do not account for damage or degradation of the mooring system over time. Once the mooring system specifications are set, operators have a wide variety of options when selecting mooring rope products. Products might look comparable, but in fact, they will all have different performance characteristics and operational results. Unfortunately, the industry has very little standardized framework to help you make deeper assessments of the line's fatigue and damage resistance characteristics. OCIMF took the first step to close this gap with their publication of MEG 4. In Appendix B, there are a series of standardized tests to help compare the performance of different products. However, there are still a lot of variables to interpret when making comparisons. Having a deep understanding of a line's fatigue, durability, and damage tolerance is critical to making an informed selection that is suitable for your operation and maintenance practices. To further illustrate this point, in the field, as soon as mooring lines are installed and deployed for the first time, their properties begin changing. As the lines are exposed to tension and extreme loading, various changes occur within the rope structure. The fibers begin to elongate, the rope abrades, and the internal temperature of the rope can increase due to a phenomenon called hysteresis. These changes result from the inherent function that the mooring lines and tails serve as the energy-absorbing components of the mooring system. With all these variables involved, it can be difficult to translate these properties onto a spec sheet, but they play a critical role in the mooring line's expected service life and ability to withstand unexpected loading conditions. If these external conditions are not properly accounted for, service life can be significantly reduced, or worse, line failures could occur. With over 5 decades of experience in the mooring industry, Samson has an in-depth understanding of our product's fatigue properties and how they respond to various types of damage. We're dedicated to sharing this information with you and helping you make better informed line selection, management, and retirement decisions.